Hello, YouTubers. This is the fourth video where we continue to talk about building enterprise-level industrial software using Microsoft Blazor. Just a little reminder, last time we talked about, validating input parameters and, making sure that every single property in the input parameter, and if you're pushing and registering a student, you want to make sure that the student that you're registering in your service is fully validated from a structural standpoint. We talked a little bit about structural validations and logical validations and dependency validations. And all of these things are super important, to ensure that you're actually covering up all the edge cases when you're building software. Now, I want you to understand this very well. Anybody, literally anybody, can build the happy path. The true engineering and the true craftsmanship comes into the part when you're trying to consider and calculate and prepare for the unexpected. The edge cases, the exceptions, all the, like by their definitions, they are exceptions. They are exception of the actual natural path that a particular software is supposed to be behaving. And because we're not perfect, because we're human beings, and because there are things out there that we sometimes don't account for, no matter how careful we are, we, programmatically try to remedy this imperfection with, handling exceptions, calculating for particular issues that may happen, and properly dealing with it. Um, so let's go back to our map here. We started with a little map, and let's go back to our map real quick. Our map here, we are still in the services area. But today we're going to talk also about, we talked about validation exceptions. I want to talk also about, the exceptions that may occur from an API. Like, for instance, what if your API is throwing a 400 exception? What if your API is telling you, there's some server error that occurred and I don't know how to deal with it? What if your API is saying that, the object that you posted, already exists? How do we deal with all of these things? How do we handle all of these different scenarios? And today we're mainly focused on that. Let's go into our OSSS portal. And just a quick reminder here, we did some validations. It validates students, so we validated, the student ID and the student user ID and all these different parameters, and we validated them with all their respective values. And then in the exceptions area here, we said if you catch a null student exception, throw this as validation. If you catch as an invalid student exception, throw this as validation. This gives you the ability. A lot of people were asking me this question, said, why don't you just, why are you handling the exception? Let the exception go all the way upstream. The reason for that is that you will have to move your business logic all the way up to your controller, and now you're going to have to write unit tests to your controller, which is an entity that you're trying to get rid of and replace it maybe with GPRC or a UI component, whatever the case may be. Always remember this. Let's go back to our architecture. This guy here, and this applies to all applications. This guy here and this guy here are replaceable. You can throw them away right here. So is this guy. You can throw them away because these pieces are plug and play. Like your business logic actually lives in these two pieces here. Remember that. And therefore, all the operations, all the edge cases, all the things that you want to, think about when you're developing, you have to maintain it within that realm. If you don't maintain it within that realm, then it becomes an edge case that you're not really accounting for. And if you try to account for this through acceptance tests or integration tests, it's going to get really bulky and really hairy very, very fast. So, we finished our brokers, we have our services. Today, while I'm talking to you about this, I'm going to have to introduce you to a nice library that I personally use, and I probably talked a little bit about this before. If you go into our brokers in here, and if you go into our API, you will remember that I used something called RESTFulSense. RESTFulSense, a group of really, really smart engineers and myself, got together and we decided to standardize the exceptions that come out of API calls. Let's go into the source code of this real quick and let me give you a quick walkthrough so you get to see what's the world look like. So new page. Let's go into GitHub. And let's go into RESTfulSense. So what is RESTFulSense? In addition to the fact that it's offering you, CRUD operations, post and get without you having to worry about the serialization and deserialization. And very recently we had a very nice contribution here from Toby, where, it allows you to actually generate Swagger and all that kind of stuff. What this library does, in addition to all of that, is that when you get an error code, it converts it to an exception that you can peacefully handle in your internal applications. So if you are getting a 400 exception, it'll throw bad request exception. If you're getting unauthorized, it's a HTTP response unauthorized exception, and so on and so forth. It makes it a lot easier for you instead of going and trying to figure out what codes, are there and trying to wrap these in exceptions and building your own. It takes care of all that magic for you. And it just tells you just handle the exceptions that come out of this, including the generic exceptions and all that kind of stuff. So you have this library here, which is great. Now, what do we do with this library? What are we going to do with all of that stuff that we have in here? Let's go into our application and start writing some tests. We're going to write some tests. You have to understand that there is a couple of things that you have to be aware of. Based on the exception that's coming from the API, you have to determine whether you want to log this as critical or log it as error. And we're going to talk about when to log this as critical and when to log this as error. Let's just start with a simple test, right? Let's go here. I'm going to create a new file, and I'm going to call it student service tests.exceptions.cs. Right? So you see every single test file also applies the concept of separation of concern. So this one is only concerned with exceptions. So this is public partial class because all of these are part of the same class. So you can leverage the existing functionality that exists in other places. And this is student service exception. Let's just write a simple test, right? So here's a fact like this. And I'm going to go here and say public async task should throw dependency validation exception on register if bad request error occurs and log it async. Every single line in this test method matters. Let me increase the font here for the people who are viewing this on their phones. Let's go with 200%. It's going to be huge. Let's see. Let's do this. All right, there we go. Let's go back to our test. Our test here is basically saying that you are going to, there's things that you have to do. Like we talked before, there are things that you have to do, then things that you need to do when an exception happens. You should throw dependency validation exception. All right, so that's what the action is. Where, when you are registering, so that's the where. When a bad request error happens. That's what every test is. You're basically saying, what would happen, where, and when. In other words, you're saying it should throw dependency validation exception where on register student when if a bad request occurs. So while the test name is super big, your brain is actually picking up on the patterns. Your brain is picking up on the patterns. When you're reading the tests, it's like when doctors, you never understand what doctors are signing. It's very hard to read their, but a doctor to a doctor, they basically look at the stuff that they're writing and they know exactly what they're talking about, right? So may engineers as well to do something very similar to that. Except that ours in here is going to be a little bit more specific and a little bit more concise. We make sure that everything does not exceed 120 characters, so people with laptops and stuff like that can still be able to see the code. I'm going to try to zoom it in a little bit for you, but no promises here. I have to be able to see the entire code base while I'm writing the code. So okay, so like we did with every test, we're going to do given, when, and then. All right, given, when, then. Great. Let's go here with something like, let's start with the exceptions that we want to happen. So the story starts as it starts. So this is bad request exception. So this will be new HTTP response bad request exception, right? And that exception takes some message inside of it. Let's put something in there just for funsies. So here is a string exception message, get random or create random string. Let's see, create random. Oh, we don't have that. Let's create one. Let's create a little method to give us, you know, a message or something. So let's go here and let's create a little method in here. And this method will basically say private static create random or get random string. And we're basically using a library called the our library here is called the Dynamics Object Filler. Object Filler basically helps you generate, you know, random things, phone numbers, IP addresses, real people name, and all that kind of stuff. So if you use mnemonic string, it'll basically give you back a mnemonic string. So this is a static string and get random string. So that's that. Let's go back to our exceptions and let's just get an exception message. Just get random string. And then in here we just need an exception. So just, you know, exception. And let's just say new exception. Like this. Since this is already a let's see, we might be having an ambiguity in here. Yeah, there's exception. So I can throw this in here. So that means I can initiate my work here with two parameters. So you have response message and you have a message. So this is your, you know, exception message like this. And then this response message is the one that actually takes the exception. Let's type this in here. Response message equal new response message, right? And let's just pass this guy in here. This is your response message like this, right? And I think we probably should leave some text in there because if you want to do your due diligence and say what the status code is, that's great, but you don't have to, you know. All right, so this is bad request exception. Let's call it what it is, HTTP response bad request exception. And then we're going to wrap this up into a new kinds of exception that we call dependency validation. So you're passing that down to a dependency, and this dependency caused a validation exception. So you're wrapping it up in an outer exception that makes it easy to categorize and react quickly based on the exception type instead of trying to figure out the how to react to every particular exception, because there's so many kinds of exceptions: null exception, invalid exception, you know, bad request exception. There are so many different exceptions, and you want to kind of purify your service to prevent it from having too much leakage from the outside world into your business logic as much as you can. It's like the ocean shore. You know, some of the water is going to come in eventually, and you need to be aware of that. So let's just go here and say var expected dependency validation exception. So let's go here and say new, and this would be a student dependency validation exception. Obviously, we did not create that exception yet, right? So let's just go ahead and create that exception. So here is students. Under students, there's exceptions, and there's a student validation exception. We're just going to copy that. I'm just going to give it a different name. I'm going to do a little bit of copy pasta here. And this is student dependency validation exception. And let's just take that guy out like this. Let's give this guy a proper name. So this is dependency validation exception, and then in here we can say student dependency validation exception error occurred. Try again. So this is basically the error code that we're throwing or propagating through the UI if we choose to do so, or basically just pass in the inner message, which is something that we're gonna do in a second. All right, so we have this exception. It's all great. Let's go here back to our guy. And let's say, okay, the exception that I really want to throw is not really the HTTP response, not the HTTP response bad request exception. This is just what I'm reacting based on. I actually want the inner exception of that, because that inner exception is what really matters. That inner exception basically is what basically has the actual issue that is happening. Student dependency validation exception. Did I not call it student dependency validation? Student dependent. Oh, I always misspell this. Dependency validation exception. All right, let's go back. Control minus. Hopefully, student depend. I actually copied it. No, I didn't. Student dependency validation exception. There you go. So this is student dependency validation exception takes in the inner exception. You will remember in the past and previous tests we only passed in the actual exception itself. Why is that? Because the exception itself will have its own messages and all that kind of stuff, so we don't really have to worry about that because we're creating these exceptions on the level itself. But in the dependency validation exceptions, these are exceptions are happening outside of that realm, and we're trying to handle it. So this is student dependency validation exception. Let's go ahead in here and mock that response. So our mock here is API broker mock. And then we want to set this up. So this is your broker and broker.post student async. So we need some student. Because the student in this particular instance is not something that's important, we use a different language. We say some student. Some student meaning the property itself and whatever that's in that property itself does not mean anything to us. We just need to make something that's valid. So it can bypass the validation tests, but still reach to the API, and that's when it just starts to blow up and actually throw these exceptions. So let's just go ahead in here and say student, some student, create random student, which we have from before. All right, so when I pass some student to my API, right, I should throws async a what? HTTP response bad request exception. So when the API is responding with 400, now I'm planning for it. I'm programming to handle this issue. I'm trying to take care of what would happen when this occurs. All right, so this is that. Now let's go ahead and write here a value task because we're going to containerize the actual process. And this is a student because that's what comes back when you're actually submitting a student. And then we say register student task. And this will be this dot service. So that's the student service. And then in here you're saying register student, and that's your some student input parameter. Great. It's all fantastic. I usually tell people it doesn't really matter when you say post student in here because we really don't care, you know, whether the input parameter reaches in here or not. I'm gonna do that. You can just go in here and say it is any student. It's not the concern of this test. I know it's really attractive for some engineers to go and say, no, we have to make sure that this test validates that the right student has been, you know, reaching to this method and function. And okay, you can go with that route. I understand it's very appealing, but you have to stay focused. The one thing I always tell the engineers about is so easy to get sidetracked, so easy to go down the rabbit hole and not be able to pull yourself out. I don't even want you to worry about that. I want you to say whatever that is being passed in here. That's just your language of saying, it's just your expression of saying, focus only on the fact that whatever happens to this function when it throws a bad request exception, you're actually able to take care of it. That's the main thing. I want you to just focus on that and don't worry about anything else. Separation of concern, radical separation of concern, down to the core. So in here, I'm saying it is any student. I'm just using some student in here because that's what I'm passing in. And then later, I'm saying await assert throws async. I always spell it as Thor. I'm a big fan of Marvel. So this should throw student dependency validation exception. And in here, we're basically going to go and say register student task as task, because it's actually a value task. So when this happens, an exception is a student dependency validation exception is expected to happen, and we're gonna react based on that. All right, that's it. Now let's verify some things. Let's verify that our logging broker well, let's go in order. So the first thing that happened actually is that the API broker has been called. So let's just verify that this broker, with whatever reach to that broker, right, regardless what it is any student. And this would help you when things get a little bit more complicated, so you don't have to worry about how do I create the right object to get down to this. You don't have to worry about that part. All right, just focus on the part where you need to verify that this has been called. So you just only for the purpose that you're verifying that this has been called once and it actually threw the exception and your code has reacted to it properly. The second thing that we want to verify here is the logging broker mock. So you want to verify that this broker in here, broker.log, we're logging error in here because it's just a bad request. It's not something big. It's just a bad request. It is same exception we talked before about same exception as. Go to the previous video. Don't worry, I'm going to put the links and everything you need. These videos are for you. I want you to be better. I want you to learn about all of these things. So I'm going to provide you with as much information as possible. And in here, this is the expected dependency validation exception. Let's take a new line for this just to make it pretty. I like pretty code. Times once. And then at the end, let's verify that no other things has been called. So the logging going to verify no other calls. And this one here is the broker API mock, verify no other calls. And this one goes before this one because of the chronological order of execution. We actually called the API broker before we called it. It doesn't matter at all from an order standpoint. It's your due diligence, it's your craftsmanship as a software engineer to actually make sure that your order makes sense. The order makes sense, the look and feel makes sense, all of that stuff. So that's a full test right here. I said there is a bad request that will happen. And then we're going to wrap this bad request, its inner exception. I'm going to push this inner exception of this bad request into a student dependency validation exception. And then I'm going to mock that this actually what would happen. And then I will verify that all of these things happen. So this is your execution. This is your verification. Some people say assert, arrange, assert, action, something like that. It's all the same school of thought. It's all meant to make your life easier as a software engineer, to be able to look at hundreds and hundreds of lines of code and be not completely consumed from a cognitive resources standpoint. All right, let's run this failing test. Control RT. I'm going to get a sip of water here while this is running. All right. Here we go. Taking a little bit of time. Come on, Visual Studio, 64 gig machine. All right, here we go. I just saw Visual Studio, sorry, Visual Basic. Who knows what's going on? Here we go. So we went around the moon and back, and now hopefully we have a failing test. Why is this a failing test? I said I expected the error that would come out. Look at this error. It says I expected the type of student dependency validation exception has happened. Instead, I received HTTP response bad requested question. That's good news. Engineers are the only ones that would see something like this. It says it's burning to the ground, right? But engineers will be happy to see this. Why is that? Because that means that you actually hit the right spot and that your current business logic didn't know how to handle that. And that's your job. That's you coming in and actually doing it and making it happen. So let's copy this test just like we did with everything else. And let's put a failing test in here. This is fail. Purest approach, pure coding, and let's go and handle that exception. So how are we going to go do about this? You see, remember that try catch, that really nice, neat try catch approach that you have in here? Don't try to look that up. I came up with that. I think it simplifies the coding. Some people like it, some people don't. I think it makes our code pretty. So if you go in here and if you see this, you'll see that we don't really handle that kind of exception. Let's start handling that exception. Let's go here and say HTTP response bad request exception. That's HTTP response bad request exception like this. And let's just go ahead and handle it. All right, let's go and do this. And we need a method like this, right? So we need to go here and say, I need a method like this. And this basically create a log dependency validation exception. So this will be dependency. I really get scared from that word now. It's very hard to spell. And this is your dependency validation exception. And this will be your student dependency validation exception. Let's break. My rule of thumb is if the lines of code inside the scope of some method are exceeding the definition of the method itself, you probably should break it, even if it's under 120 character. Just try to make. Let me explain something to you. When you're looking at code, your brain doesn't really just look at the letters and the colors and the logic of it. Your brain sees patterns, right? Your brain sees patterns, and when your brain sees patterns, you will notice immediately that if the patterns are comfortable for the naked eye, for the engineer eye, they will be willing to actually spend longer time looking at your code or working on your code. You have to make the code actually attractive to the engineers. And one of the ways that I do this, and I advise people to do this, is to be able to make sure, like, if this is the line of code, let this be the rule of thumb, let this be the end in here, and make sure that all the lines of code, like, if this goes like this is probably still less than 120 character, maybe. It's exactly 119, but it looks weird. Look how it looks. It goes outside of the method, and there's no intent of making it look better. So why don't you just break at the equal sign in here? Make sure you have a new line between every two-liner statements, and the return statement should have its own. Go back to my coding standard guideline. I try to update this every now and then. It's not in the best state, but I continue to update it as much as I can. All right, so I broke this apart a little bit. So this is student dependency validation exception, and this is our guy. Because this is a dependency validation exception, we're not really throwing a null exception. This should just be exception. And by the way, this also should just be exception. I shouldn't have called this null because it could be anything, except that this dependency validation exception actually takes the inner exception, not the outer. The outer is just a very generic message that doesn't mean anything. We want the inner exception that actually has the real message that's in it. So that's your inner exception in here. Let's go in here and say create and log dependency validation exception, and you're just passing in your HTTP response bad request exception, and here we are. This is pretty good. We're still within that realm. Fantabulous. All right, so that's all of this. Now let's see why this guy here is complaining, because we need to throw this. So now that we're throwing that exception and we're handling the bad request exception, let's go ahead and run it. Let's go ahead and run our test again. So here's our test. Here's our failing test, and let's run it, and let's see if it passes. Programming requires a lot of patience and perseverance. You have to be willing to go the extra mile and willing to sit down and be patient and understand how things work in order for you to achieve something worth its while in this industry. You're going to fail and come back up and fail and come back up, but that's what this industry is about. All right, this guy's still failing. Let's see. Object reference is not set to an instance of an object. We probably didn't build our stuff well. Let's see. Is this HTTP response message has a status code exception? Oh, I'm sorry. That's my bad. On this level of exception, we actually don't need to do the inner exceptions because it's already coming in with a good message in it, so you don't really have to worry about that part. Let's examine this real quick before I just make any conclusions. Let's just do Control RT like this, and let's see if we're actually accessing the right information. All right, so this exception here, I don't think this guy has inner exception, and it just has the message, and that's how it's going to come in from. Yeah, see, it doesn't have inner exception. So at this level, maybe in upper levels, we will be looking at the inner exception. For this level, we don't really need to look at the inner exception. That's my bad. And then let's go back here and take care of this because it's already coming in with one layer of exceptions. That's how, at least, how I built the library. So let's go here and just take off this guy here. This should be good enough. Let's go back and run our tests. Here we go. Is it going? There you go. So that test has passed. So that's us handling one of the most common errors that happen from an API, right? You get a 400 exception. What's going to happen, right? So that's pass. Let's make another one, right? Let's try to aggregate all the ones that complain. There are ones that are critical and dangerous, like unauthorized exception. What are you going to do there, right? Or HTTP request URL not found exception. This is one of the hardest ones that I actually had to solve with Ali. The problem with this is that what if you're hitting an API and the endpoint doesn't exist? We need to log this as critical. What if you're hitting an API and the authorization is not in place? We have to handle this as critical because that impacts the entire communication within your software. So you have to be careful with this. So let's just go ahead and do this. Public async task should throw critical dependency exception on register, right? If not found error occurs, if URL not found error occurs, and log it async. Oh. So what is this all about? You're hitting an endpoint and the configuration in your application is bad. You're hitting the wrong endpoint. The endpoint doesn't exist. There's an extra character in there. The server is down, the URL, whatever the case may be. You want to log this as critical exception. So it's something very similar to what we did here in this guy here. I'm going to copy all of this here. The only difference is, and because we're using RESTFulSense, you could actually go here and say HTTP response URL not found exception. Look at this. URL not found exception. I probably upgraded the library and didn't upgrade it in here. Let's upgrade the .NET, the Nuget package, because this is very brand new stuff. I think it's less than a month ago. Let's upgrade this library real quick. There you go. Updates. Come on, come on. Not letting me. Let's see. 1517. Here you go. Update. So if I update this, you'll get that new exception that tells you actually, because you're getting 404 both ways. Like if you're searching for an object in a RESTful API, it'll say 404, the object not found. That's not critical. That's just you passing in an ID, and the ID is bad. It doesn't really correspond to anything. But what happens when you hit an endpoint and it returns the other 404? The other 404 in this case is that the URL is bad. It's not found. So what do we do then? So here it is. So this is HTTP response URL not found exception, and there's another one that's not found exception, which is not really relevant in this case because you're pushing. You're not really retrieving. You're pushing data. We will come back to not found exception, which is not critical, when we do pulling the student. Don't worry, this is a long series. I'm going to do as much as I can to show you all the things that happen in here. So okay, so this is HTTP response URL not found exception. And in here, this is going to be student dependency exception. So this is not a validation exception. This is a dependency exception in the sense that configuration is bad and something broke, right? Let's go and create that exception. We don't have that exception in here. Let's go ahead and copy validation, paste it in here, copy pasta, copy pasta. If you know what you're doing, you can eat all the pasta you want. Just make sure you don't copy pasta too much to the point where people don't know what you're developing anymore. Things start looking like each other and find some embarrassing moment when you're saying student dependency exception when you're actually hitting the teacher endpoint or something like that. So don't let that happen to you. This student dependency error occurred contact support. Why contact support? Because this error is going to propagate all the way to your end users. And in that case, you want them to reach out to you and say, hey, it says contact support. And you should. You should be contacted. If it's a validation issue, they should take care of it. If it's 400s on their side, except this kind of 400, that's definitely something on your side that you need to take care of, whether on your dependency side or your configuration side. So there's student dependency exception. It says expected student dependency exception, something very similar to all of this. And then we're going to copy this in here. So this is student dependency exception. The only difference here is that when we're logging, we're actually logging critical because that impacts your entire application. And when we say log critical, you have to understand something. When engineers, try to categorize the logging that happens in their system, it helps you determine whether you need to react immediately or react later during work hours or whenever you're ready to work, or not react at all. You know, not react at all meaning that, oh, it's just a warning. It's not something to wake up in the middle of the night and have to fix immediately for a 2 or 3, maybe 10 million user enterprise system, right? Some of these things, especially to OSSS, the application that we're building here, OSSS is going to be very, very critical because it's going to be running schooling systems, around the world, right? And in order for that to happen, we need to make sure that our system is really, really well thought out and really, really strongly, developed and designed. So we make sure that the future of people depends on some of the data that is going, through your API. You have to make sure that this is a reliable system. So we log critical, meaning wake up immediately and fix it. Wake up immediately and fix it. This is not a joke. So this is log critical exception. Something in your configuration is bad. Let's run our application. Let's see what happens. So that's before I forget. Instead of this HTTP response bad request exception, it will be URL not found exception. This is very, very important for you to be able to write actually industrial software. So let's run this. Let's put this down a little. This should fail, should throw critical dependency exception on register if URL not found error occurs on logit async. All right, so this guy failed. It basically said I expected a dependency exception, but I got HTTP response URL not found exception. So let's go ahead and fix that, right? So let's first commit this and say this is a failing test. And then let's go and fix it. Let's go into register student async like this. And in the try catch, let's go handle that exception. I prefer to put the critical exceptions before the non-critical exceptions because critical exceptions are infrastructural. They are more likely to happen in that order before you actually get validation. If there's a problem with your URL, definitely the critical exception is going to occur before you actually get to the bad request. So let's just do that in here. Catch HTTP response URL not found exception, HTTP response URL not found exception, like this, and then throw create and log critical dependency exception. There it is, HTTP response URL not found exception. And let's go create that method. It's going to be very similar to this one, so let's just take this one here. And we're just going to go and say, instead of validation exception, we want a dependency exception. That's this and that. Instead of logging error, we're logging critical. Oh, log critical. And this is, instead of dependency validation exception, it will be just dependency exception. So log critical, student dependency exception. You need to make sure that your code makes sense. This is dependency exception. Here you go. All right, so this is that kind of error. So in here, log critical dependency exception, create and log critical dependency exception, and this guy will be happy. Great. So we handled that. That means we can go back to our test and run it again. Here's our test, and let's run that guy again. Here we go, and that guy passed, right? What other critical issues that may happen in your system when you're trying to communicate with a particular endpoint? We want to combine those, right? We want to combine those. Another issue that could happen is that if you get unauthorized exception. Unauthorized exception meaning your token has expired and the system is incapable of communicating with the other system anymore, especially if it's API to API communication. You have to understand there's two kinds of communications that people in in enterprise, software enterprise world, they say there is offline communication and online communication, right? Offline communication when a service is talking to a service, in the cloud or an enterprise system without a user having to be present. So it's not really using an existing user that's logged in token to actually communicate with a particular service. No, it's an offline service. It's running during the night behind the scenes. People don't even know it's running. It's like, the daemon services that are running in some system and some enterprise applications. It's running behind the scenes. That's creating its own token, authorizing with other services, and securing its pipeline. Some people vote for not having to secure that pipeline between a server and a service as long as they're living within a virtual private network. That's fine, as long as there's a gatekeeper that protects other things from communicating with your services, or your service communicating with other things without authentication. Sure, why not? However, you might get that exception if your service is trying to authorize against a particular service as an offline communication. Even if it's an online communication, you still want to critically log this, because that is possibly a student that's trying to do their exam, trying to submit their homework, or someone that's maliciously trying to access your system. You should get a critical error immediately and investigate and see who's trying to access your system and access information of some students. So the other case, it's the unauthorized. How do we take care of this? Obviously, this is also taken care of with the library, the RESTFulSense library. If you go in here, you will see unauthorized, and it's HTTP response unauthorized exception. And I have made sure that you have all the kinds of, errors that you may need. Some of them you may need, some of them you won't, right? There's like payment required, 402. We don't need that, it doesn't mean anything for us. Forbidden, maybe. Maybe you need forbidden. You need not found when you're pulling data that is not there. You need not found, URL not found. See, both of them are URL 404s, but I'm giving you two different exceptions so you can distinguish between this, because it's like heaven and earth. It's a big difference between the two. You have to pay attention to that. So let's just go back to this guy here. So I want to handle this the exact same way I handled this one. Well, why don't we just use theory data? Some people might ask me, what is this theory data? Theory data is basically, you go here and you say public static theory data, right? And you call it something, right? Let's call it, critical API exceptions. So these are critical API exceptions. And these critical API exceptions, basically, we have a couple of them. We have var, HTTP response, URL not found exception, which is the one that we just took care of. So let's copy all of this in here. I'm going to take all of this and put it in here. So this is one of them, right? HTTP response, URL not found exception. And the other one, we could do HTTP response unauthorized exception, like this. So this is HTTP response unauthorized exception, and it basically takes a response message. Sure, response message, and it takes a message, which is the exception message. Whatever that message is, it doesn't matter. You want to add in the code, sure, go for it, why not? So you have these two. Now you can return new theory data of exceptions, like this. And that theory data has these two elements, the HTTP response URL not found exception, and HTTP response unauthorized exception. So if you return this, this is basically theory data. It's calculated data. It's that data that I have to build so you can send it down to your unit tests, and your test is going to behave technically the same. We're going to log critical and all that kind of stuff. So what does that mean? It means that we need to switch this into theory, because now it's handling different input parameters, different cases. And we want to pass in here critical HTTP response critical exception. We're just going to call it something generic that fits everybody. And then in here, did I type exception wrong? Yes, I did. Exception, like this. And then in here, you want the member data name of the calculated exceptions that we have in here. Does this work? Yeah, look at this. It works. And then this critical exception that we've created, we can put it in here. Now everything will behave just the same. The only difference is that your test looks a lot neater, a lot cleaner. You know exactly what kind of data you're passing in. Obviously, you could push this into your centralized node test, student service test, but if you don't want to, that's fine. I'm all for visibility. I don't want you as an engineer to jump between 2 or 3 files just to find where this data is coming from, unless it's shared across multiple files, and maybe that's fine. Maybe that's fine. So all right, so this is a theory data, and it has two different cases. So that means that it will fail sometimes. It will fail in one case and pass in the other, because we already handled the URL not found exception. Let's do Control RT on this one, and let's see how things work for us. There we go. All right, there you go. If you expand, it'll tell you I passed on one and I failed on the other. I passed when it was URL not found exception, and I failed when it was HTTP response, unauthorized exception. Let's just go ahead and fix that. Let's go to register student. Actually, let's just first commit that this has failed. And then let's go ahead and register student async, try catch, and let's go ahead and handle that other critical exception. So unauthorized can only happen if the URL was found, right? So if you have a URL but you are unauthorized, so let's put it in here. HTTP response, unauthorized exception, HTTP response, and authorized exception. And let's go ahead and do exactly the same thing that we did in here, like this. All right. The only difference here is that the message here is different. So this is unauthorized. There you go. So this is the unauthorized exception that we're trying to take care of. Great. That means I can go back here into my test and run it again. And it passed, right? So that means that we actually can handle all the potential critical exceptions that may happen, right? So let's just go ahead and log this in as a passing test. Pass. All right. What other exceptions do we need to handle, right, when you're posting a student? It's up to your API. What does your API do that allows you to do that? If we go to the actual API that we're talking to, don't handle exceptions that you don't understand, and don't handle exceptions that you don't have to. So let's just go ahead into my repository here, and let's go to our API. And if you go into the API piece, if you go into controllers, and if you go into student's controller, this is the post. So what kind of exceptions are we throwing? We're throwing conflict exception when the student already exists. So we need to handle that as a dependency validation exception, right? And also we throw bad request and we throw 500 amongst the other two things that we talked about. So these two are dependency exceptions. This one is a dependency validation exception, dependency validation exceptions, and this is 200. The world is all in good place. Let's take care of the conflict part. It looks like we already have taken care of a dependency validation exception here when we threw bad requests. So why don't we do the theory data here again, except that this time it's going to be taking care of non-critical errors. So I'm going to copy this guy here and put it right on top of its designated test, like this. And let's just go in here and say bad request API exception, because all your 500 errors are technically bad request. All of them are validation, API validation exceptions. Let's just call them API validation exception. That's better. Validation API exception. So it's critical, and this is validation API exception. And what we're really trying to do here is HTTP response bad request exception. That's number one, which we're already taking care of. Bad request exception. And then the other one is here is what? Conflict exception. Response conflict exception, which I think is 409. Response conflict exception, like this. So let's see, if this is conflict exception, we're going to put this guy in here. It's going to say, okay, this student already exists. It's not really a critical issue. It's just telling you that this is a dependency validation exception, which means that this guy has to change. And we're going to go here and say member data, name of validation API exception. And in here, we need an input parameter. So this is going to be exception, validation API exception. And let's take this guy and let's remove all of this and simplify our test a little bit and take this validation exception and put it in here. Everything should just work. This test should have one passing case and one failing case as we go. So let's just go ahead and run this test real quick. Here we go. All right, there we go. So this is two failing cases, one failing case, the one that passes HTTP response bad request exception, and the other one is HTTP response conflict exception. All right, so, well, in that case, let's just go ahead and take care of that. Let's first commit that test. So that will be fail. And let's go and take care of that on the exception level. So this is HTTP unauthorized bad requests. It's very likely that you will get other bad requests, but let's handle the specific cases because bad requests could cover a lot of different things. So this HTTP response conflict exception, HTTP response conflict exception, and this guy will be treated exactly as we treat this one, with respect and dignity. There you go. So now if I go back here and do Control KD and go back to my test and run this guy, hopefully this guy will be passing now because that means I'm handling the conflict. It's all about, you know, how you implemented your backend API or the Swagger document or whatever contract, whatever team you're dealing with. They should tell you what kind of errors they're throwing, not just the happy path, right? Here you go. So this guy passed. That's great. Let's go ahead and submit that in. Pass. Now, what other exceptions do we need to handle? We handled dependency exception, we handled, you know, validation exception and all that kind of stuff. There are two others, you know, the 500 exceptions that come back, right? These are internal server errors. So let's just take care of that while we're at it. So let's go here and take care of the internal server error exception, which is basically going to be probably something similar. Well, not really logged in as critical because that's just a dependency exception. Let's take care of, let's copy this one instead. Let's go and take this test here. And let's go down here and say, should throw dependency exception on register if server internal error occurs and log it async. Obviously, you have a wide range of exceptions that you may need to take care of. For this one, for the purpose of this project and application, these seem to be, for what we know, seem to be very conclusive, you know, in addition to a couple of more tests that we're going to add shortly. But okay, there's this guy. Let's also get the creation of the the exception. So that's internal server error. Let's go here, and that would be HTTP response internal server error exception, which means that this guy will be internal server error exception. And that means that this guy is going to look like this, this guy is going to look like this, and everything should be the same. So it's a student dependency exception. This should not be validation, should be dependency. And we're going to log this as error. And expected dependency exception, we should call it student dependency exception. Like this. So that's student dependency exception. And we don't need the validation piece. All right, this guy should technically fail because we don't have any protection against 500 exceptions that are coming from the server. So let's do Control RT here. And this guy is failing. Hopefully it's failing. Just because your test is failing, don't just, ship it over to your pair or whoever you're working with. Just make sure it's failing for the right reason. So it says, I'm supposed to receive a student dependency exception, but actually you threw a student server, internal server error exception. Let's go ahead and put this in here and say this fail. And now let's go ahead into the register student. And let's go ahead and handle that, right? So we're going to handle that with HTTP response internal server exception, HTTP response internal server exception. So that means we can go here and say, do we have, so we have create and log critical dependency exception. We want to log non-critical dependency exception in here. So we have dependency validation, critical dependency, and then there's dependency. It will also be service exception. We'll come to that in a second. So this is dependency. The only difference here is that we're saying log error. So it's non-critical, right? Let's take this guy here and say throw, create and log, HTTP response. Because internal server error is very likely to be something on the server side. Even if it was something that you sent in, it's still the responsibility of the developers that developed the API that they didn't protect their API enough, to not, fall apart because of a request. If it's falling apart because of a request, they should return a 400 exception, in which case we'll be able to handle it. But in this case, they're not. And in this case, we're just saying, oh, this is the dependency. It's their problem. Report the problem. Do your due diligence as a good citizen, but don't, wake up in the middle of the night and try to fix it, because sometimes you don't own these resources. You have to take care of it yourself. You don't have to take care of it yourself. So let's go back to our test here and let's run this guy once more. This is test driven, step by step, fail, pass until you reach the end. This is fully developing all the different aspects of a service from a validation standpoint, from a dependency standpoint, from an API integration standpoint, and in a little bit it's going to be also from a service standpoint. So here's this guy. Let's go ahead in here and say this guy has passed. Beautiful. All right, now what? Now there is one last thing we need to take care of, which is the generic HTTP response exception. I made sure that this is there to make sure that you are that any exception, no matter what it is taken care of. Your API may throw some, like we handled the exceptions that we think more likely to happen. But what about the other, I think there's like 20 of them or something. What about the other exceptions that are forever growing and increasing? Let's find these exceptions. What about these guys? All of these different exceptions. What if people changed their API and they didn't tell you? Right? You're supposed to be able to handle that. You're supposed to be able to work against, the unexpected, like a catch-all kind of thing. The challenge that we're trying to solve here is that if any other error has been thrown, we need a catch-all, like a generic exception type. But we're not going to use the generic exception type for this one. We're going to use something called HTTP response. I'll show you. The generic HTTP response exception, which is not even in here. You could see it in the models. There's something here called HTTP response exception. Too many exceptions. There, HTTP response except this guy here. And I built this guy specifically. It doesn't really abide by a particular error. It could be 400, 300. It doesn't matter what the error is. If it's an exception, if it's a failure, it's a failure. If it's none 200, it's an exception, right? And how I handled this is that if you look at your clients, really, there's a little service in here that takes care of your exception validation service. And all the way at the bottom in here, I'm basically saying if you run out of error codes, if you run out of everything, response exception. Let's see. This is your not found, clients, factory. This is your API calls that you're making. And this is models and services. And right, if the content is not there anywhere, then we want to throw HTTP response exception. So this is, let's search in this project. Models, exception, this guy right here. This guy is the most generic guy that you're going to get. For whatever HTTP response error that we can't deal with, it should take care of that for you. Let me just find it for you. I'm really adamant on making sure that you get all the information you need and answer all the questions you have. So in this repository, so this is where everyone is inheriting from, right? And is that all what we did with this? Because most of these, yeah. So this is like most of these are inheriting from that. So if you run out of, yeah, so most of these exceptions are inheriting from HTTP response exception. And this HTTP response exception is basically what is going to be thrown in general if you don't end up with any of those. Anyway, I'll put some description for you in the link of this video. Let's just go and handle that one. This HTTP response that we don't know what error it is and we couldn't understand or really work around what that error is, an unexpected error that you need to take care of. We could use theory data in here as well, just like we did with the other ones. So just like we did here, this is a dependency exception. Why don't we just use theory data in here and go and say API dependency API exceptions. So we call this validation API exception, critical API exceptions, and this is dependency API exceptions. That's what we really want to handle in here. So let's see if we can take care of this. This will be both HTTP response, the generic one, response exception. That's the big guy that handles everything, the equivalent of exception. And the one that we're really trying to handle in here, which is basically the generic internal server error exception, which is this guy. Both of these will be treated the same, right? So this is response message, and I don't even think this guy takes HTTP response message and message. What's it take? HTTP response message. Yes, there you go. HTTP response message like this, and it takes the response message and works with it. Right, let's change the name of these a little bit. So HTTP response exception, that's the big guy. And then this guy here is the HTTP response internal server error exception. This guy is basically telling you if you run out of things to handle, just take care of this one. So there's this guy here, and let's go ahead and turn this into a theory. And this will be member data, name of dependency API exceptions, and we need to put that in just like we did with the other ones. Exceptions, dependency API exception. And now we can delete all of this and instead put this in here. And everything else should be the same. We log it as an error, we throw it as a student dependency exception, and so on and so forth. Now if we run this guy, it should fail. Now I remember. All the exceptions that are being thrown, we don't really throw the exception itself, but they inherit from that exception. So if they match the same type, they will basically throw and you will be able to catch it because polymorphism, right? You're basically saying handle exception. That means anything that inherits from that exception. Back in here, everyone is inheriting from HTTP response exception. So even if you didn't handle a particular exception, you'll be able to capture HTTP with generic exception and treat it as an internal error. So now we have two failing tests. Let's take this guy in here, and this guy fails. Let's push this in, and then let's go back into our register student async. And in here, I'm going to handle that guy. Let's go back here all the way at the bottom and say catch HTTP response exception. All right, and then throw, create, and log dependency exception. Here we go. And that should technically make your test hopefully pass. Let's see. Here's our test. See how we're aggregating all these different cases and categorizing them based on how we should react from an API client to API perspective. How do you take care of this situation? So this guy passed. Let's put this guy. Let's make sure it has the right. Yeah, if server. Let's just say server, and instead of server internal error, you know, if dependency error occurs. Server, if API dependency error occurs, like this. Dependency API error occurs is better. I'll take the time and I'll refactor it and make sure it actually looks right. It's worth it. So, all right, here we go. So this is pass, and this is done. So that's the phase. So we handled two things now. Validation exceptions and dependency exceptions, the critical ones, the dependency validations ones. There's one last thing we need to take care of, and we'll be done with this service. This entire service, we handled all the exceptions and all the validations. Now you actually have rigid, strongly programmed, thought through software that actually doesn't let anything go through without validating it and examining it. So the last test we want to do here is something for all the other exceptions that we couldn't actually catch. So we caught all the exceptions that may come from an API. Now we want to capture the bigger picture, the bigger picture, which is what I call the service exception. So in here I could go and say value task should throw service exception. So it's something happening on your API, on your UI in here. Service exception on register if error occurs, generic error occurs, and log it async. So what does that mean? A simple exception that falls, you know, that you haven't really accounted for outside of the API communication, whatever that may be. It could be memory leakage. It could be anything, really. You want to account for that to build actually strongly thought through software, industrial software. So let's just start with this. We could say it was var service exception, new exception, like this. And let's create some student while we're at it. Some student. Because we really don't care. Create random student. And then let's attach that service exception. You gotta attach that service exception to something. So just for all intents and purposes, we're gonna attach it to the API call, even though it doesn't necessarily come from the API call. So let's just go here and say mock API broker mock setup whatever. So this is broker dot post student async. It is any student. We don't care. Outside of the purpose of this, and this will throw asynchronously a service exception. Doesn't necessarily have to come from the API, but here we are. This is the attachment, the process that we're attaching our mock to, which means that in here we should have expected student service exception. This is this logic service exception. New student service exception. And I don't think we created that yet, so let's just pass this in here. Let's go create that exception all the way up here. We have student validation exception. Let's copy pasta this one. And let's put that in here. Student service exception. And this will be student service exception. There you go. And we copy that here. And we want to make the message make sense. So this is student service error occurred. Contact support. Contact support because you can't actually do anything about it. As a user, you can't do anything about it. As an engineer, I hope you can do something about it. So alright, so this is expected student service exception. And then just like everything else, I think we could actually even use this guy in here. Like this entire portion of the system can be pasted in here. So it's just you saying expected student service exception. You're logging an error and you are expecting a student exception to occur. And here we are. So this guy should fail. This is the last exception and the last thing we need to do about this service. So let's run this guy. There we go. And this guy is failing. Is it failing for the right reasons? Yes. It says, I expected you to throw student service exception, but you actually threw the generic service exception. Let's put that guy into perspective. This is fail. And let's make this guy pass by going into the exceptions area and handling the last one. Let's create a method in here for this. Create and log service exception. So we need student service exception. And that's this guy as well. And this here is student service exception. And that's this guy. We're logging it as an error because we don't know how critical it is. And we don't want to wake people up for no reason and page them for no reason. So catch exception, service exception. And this here throw, create, and log service exception. This is service exception right here. That's it. The last one. Let's run our test and kiss this service goodbye. We don't have anything else to do with it. Obviously, we're going to come back to it for other CRUD operations, but this is just covers up the creation of a student. See how rigid this is? This is how you build enterprise applications. Everything has to be accounted for. You have to handle every possible exception. It takes time, it takes effort, it needs patience. You need to sit down and think about what you're doing. Don't just write code that you can't maintain. Don't write code that doesn't handle all the cases. Murphy's Law, Murphy's Law, Murphy's Law. Whatever can happen will happen. Don't say, oh, the user will never do this. That's not realistic. So here, this guy is passing. And this way, let's run all our tests just to confirm that everything is good. We have about 23 tests in here. So let's run everything. Sometimes Visual Studio is weird about yeah, I have to do it step by step like this. How fun. So there you go. So these are all your tests. You have service tests. We handled all the kinds of exceptions. If you go into look at your service, let me collapse. It's about 200 lines of code worth of just the exception handling. And then you have the validation. So the input parameter is being validated in all different dimensions. And your code still looks simple, which is what I really care about. If you go into your services, student service, this is the subject of test. This is what we're really testing, right? It has in one side, as a partial class, it has all the exceptions that may occur, all abstracted away from sight and mind. They are exceptions. They should not be there all the time in front of you. And all the validations. We have all the validations also on the side. And then you get to look at this service and actually just completely focus on this aspect. Please understand this. When people say object-oriented programming, an object like a mouse or a phone, an object has different aspects, right? It has different aspects. 3D, right? An object is 3D, right? So there should be an aspect in here where there is exceptions, and an aspect in here when there is validations, and there's aspect in here when there is logic. And in the future, I'm going to talk to you about, the rollback aspect and all the different possible aspects that may come into play. The extension aspects. There are so many different things that surround one object. So if we consider our service here, our student service here, to be an object, then we have to handle all the aspects of the operations that this object performs. All the operations that this object performs. And with that, that makes me very proud to say that this model in here, oh, I went a little bit too far. Where are we? All right, lost track. Where are we? Hold on. There we are. Right here. So that means that this here is completed. This guy here is fully completed. And this guy here is fully ready. We are ready now to move on to the next thing, right? To move on to the view services. And that's what we're going to be discussing. I keep losing it. There it is. And this here is the guy that we're really going to be looking into next. Next session, we'll be talking about the view service. Think about view service as the MVVM kind of model. You're creating a student view model, and you're performing all the possible operations. Obviously, there won't be as many work needed for a non-broker neighboring service like we did with this one. A broker neighboring service, is the one that it's the last point of contact before you work with your external dependencies, whether they are storage, whether they are APIs, queues, email services, whatever the case may be. So you would expect a lot of validations that happen on a broker neighboring service like the one that we just worked on, right? Not so much on the mid-layer services like view services, orchestrations, coordinations, processing, and aggregation and management. These services don't necessarily have as much of a heavy validation and exception handling because they're very tiny cases, because you already took care of that from the bottom. It's like a pyramid that you're building all the way up. The higher you go, the less, the breadth of the work that you're doing, is going to be, although that the higher you go, the more decision you have to make, and that's where the core of your business logic is. There's so much stuff I want to share with you. I thank you so much for watching through this video. Please, go to the source control, look at this stuff in real life, run the application locally on your machine, try to learn from it. Hopefully you'll learn something from it. And, if you have any questions, comments, or concerns, feel free to drop a comment in the comment section. I'll be more than happy to answer your question. And do not forget to like and subscribe. Thank you for watching. See you in another video.